Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. Today's lesson is all about Unit 6, Lesson 6. This is actually the last lesson of this entire unit. So good job working your way through Unit 6. Today we're going to be graphing radical functions and talking about how to find the domain and range of a radical function, how to graph it, all that good stuff. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. So today's objective is I will graph radical equations, describe transformations, and state domain restrictions. Mastery will be demonstrated by scoring at least 80% on today's extra practice. So the parent function of all radical functions, or all square root functions, I should say, is f of x is equal to the square root of x. So f of x is equal to the square root of x is a graph that we actually already talked about and worked on transformations of in Unit 2, Lesson 5, I believe, of first semester. So we've already seen this function. We've talked about it a little bit. So this shouldn't be the first time you've seen it, but I know that was like a long time ago, so I don't expect you to remember everything we did or said. Now, the graph of this function, so f of x is equal to the square root of x. There's a few things we need to talk about. When I take the square root of x and I want to graph it on the real number plane, so I'm graphing it on the real coordinate plane where we only have real numbers. Well, when I take the square root of a negative number, I get imaginary numbers. And I can't graph imaginary numbers on the real coordinate plane. I can only graph them on the imaginary coordinate plane. And so since we're using the real coordinate plane, we only want to focus on our real solutions. So we only want to use x values that will be positive. So that means that when I talk about my domain, I want x, what's under the radical here is x. I want x to be positive. So x has to be greater than or equal to 0. Well, if I put that into interval notation, so for my domain then is the least value I can use for x is 0. And then I want all the positive numbers after that. So to positive infinity. So my domain is from 0 to positive infinity. Now, to find the range of our radical functions, the way we're going to do that is we're going to take the least value we're allowed to plug in for x, which is 0, and we're going to plug it into our function. So to find the range, we're going to take the least value x can be, which is 0. We're going to plug it into the function. So we're going to get y is equal to the square root of 0. So y is equal to 0. And what that tells me is that 0 is the least number y is going to be as well. So my range, therefore, is 0 to infinity. So for our domain and our range, in this case, for the parent function, they're actually the same. All the x values go from 0 to infinity. All the y values also go from 0 to infinity. So now let's talk about our starting point. So our starting point then is the point, well, our x values start at 0. When I plugged that into my function, I got 0. So my starting point is at 0, 0. So I'm going to go ahead and put that on my graph at 0, 0. Now, as you can see, that starting point of 0, 0 is also our x-intercept and our y-intercept. Because it's at the origin, that is our x and our y-intercept is the same point. So our x-intercept is 0, 0, and so is our y-intercept. All right. So now to find some other points on our graph. Well, if the least value that x can be is 0, and we got 0 for f of x, then the next number I want to plug in is probably 1, because I can't go to -1. X can't be negative in this case. So we have f of x, f of 1 would be the square root of 1, which is 1. Then I could plug in a number like 2, but when I take the square root of 2, I don't get a whole number. I get I don't get an integer. I get a decimal, which is fine, but I don't want to deal with that right now. Well, if I plug in 3, I'm also just going to get the square root of 3, which is also decimal. Don't want to have to do that in my head right now. So the next number I'm actually going to plug in is 4. And the square root of 4, so f of 4, the square root of 4 would be 2. Then what's the next integer we want to plug in? 5, 6, 7, 8. Let's do 9. And the square root of 9 would be 3. So let's plot those points. So we have 1, 1. We have 4, 2. We have 9, 3. And then we have all the points in between, but our starting point's at 0, 0. So I'm going to put my pencil there. I'm going to start at 0, 0, and I'm just going to connect these points. And I see my graph just continues to extend all the way to the far right. And if I keep plugging in values, like if I plugged in 100, I would get 10. And I can see that my graph is extending in that positive direction on the X and the Y axis, and I would eventually reach 110 if I were to plug that in. The square root of 100 is 10. Okay. So there we go. We've answered a few questions here. We've talked about our y-intercept, our x-intercept, our domain, our range, our starting point is 0, 0. Now let's talk about some transformations. So we can actually take this parent function that started at 0, 0 and extends all the way to the right. It's just this little, kind of like half a parabola, little curve. And we can shift it up. We could shift it down. We could shift it left. We could shift it right. We could do a horizontal shrink, a vertical shrink, a vertical stretch. We could reflect it over the x-axis. So we're going to talk about those kinds of transformations and what that looks like in the equation. So if we're talking about the parent function, f of x equals the square root of x, if I take a number and subtract it directly from x, so I have the square root of x minus h, and x minus h is under that radical, that is going to shift our graph right that many units. And we've talked about transformations before, so this should look somewhat familiar. When I take a number and I add it directly to x, I'm still under that radical. F of x is equal to the square root of x plus h. I'm taking the square root of x plus h. I'm going to shift left that many units. Then if I take the whole function and I add k to it, because I'm adding a number directly to the y values, then my graph is going to shift up that many units. So what's going to happen when I subtract k from the entire function? So I'm subtracting k from the entire function. We're going to shift down that many units. I just realized I wrote an h there and meant to write k. We're shifting up k units, we're shifting down k units. Then if I take a number a and I multiply it by the square root of x, I want to use the absolute value of a in this case. So that means that I'm going to, if the absolute value of a is greater than 1, we have a vertical stretch. So if the absolute value of a is greater than 1, then f of x equals the square root of x has a vertical stretch by a factor of that absolute value of a. So our graph is going to stretch vertically. If the absolute value of a is between 0 and 1, so it's a number less than 1, but it's greater than 0, so it's still positive, but it's less than 1, so it could be like 0.9, 0.8, 1/2, 2/3, 1/8. Then your graph has a vertical shrink. So we're going to have a vertical shrink by a factor of the absolute value of a. And then if you take the entire function and you multiply it by a negative, you're going to have a reflection over the x-axis. And when you're graphing transformations, you always want to do your reflection first. So always reflect first. All right, let's talk about some transformations of the parent function. So in example 1 here, we have f of x is equal to the square root of x minus 2 plus 1. The first thing we're going to do is describe our transformations. So how does adding 1 to the entire function, we're outside of that radical, we're adding 1 to the entire function, how does that transform the parent function f of x equals the square root of x? So that transformation is we shift up 1. One unit. Then I see that I'm subtracting 2 directly from x under that radical. So when I subtract a number directly from x, my graph shifts right that many units. So we're going to shift right 2 units. So now let's talk about some key features of our graph before we start graphing. Specifically, I want to talk about the domain and the range. And we're going to find our starting point. So for our domain, we know that whatever is under the radical needs to be positive. So that means that x minus 2 has to be greater than or equal to 0. And if I add 2 to both sides, I know that x has to be greater than or equal to 2. So the only x values I'm allowed to plug into this function are the x values that are greater than or equal to 2. So my domain starts at 2 and then goes to positive infinity. Now let's find our range. So to find the range, you actually just take the least value your x can be and then plug it into, just kidding, that's the parent function, plug it into the function. So we're going to take, I'll show my work over here. For my range, I'm going to take f of 2 is equal to 2 minus 2 plus 1. And f of 2 then is equal to the square root of 0 plus 1, which is just 1. So my range starts at 1 and goes to positive infinity. So our starting point then is actually, our starting point starts where our x values start. So it will be at the point 2. And then when you plug 2 into the function, you get 1. So our starting point is at 2, 1. So I'm going to graph that. Our starting point's at 2, 1. And as you can see, if you compare that to the starting point of our parent function, which was at 0, 0, so 0, 0, we shifted right 2 and up 1. Isn't that what we predicted would happen with our transformations right here? Shift up 1, shift right 2. So we were right with those transformations that we described. All right. So our starting point is 2, 1. And we need to find some other points on this graph. There's a couple ways we can do that. We can use the points that we found for the parent function. We could go back, just kidding, I'm sorry. And take 1, 1 and just shift it up 1 and right 2. We could do the same thing with 4, 2 and 9, 3. We'll just take these points from the parent function and just shift them up and to the right. Or we can find more points mathematically. And to do that, we would find some things that we can plug in here. So the next perfect square would be the number 4. And to get 4 under my radical, x minus 2. What minus 2 would be 4? Well, 6, right? So I'm going to plug in 6. You can plug in any numbers you want that are greater than 2. So if you wanted to, you plug in 3, you plug in 4, 5, all that good stuff. I'm going to plug in 6 because what happens is the square root of 6 minus 2 plus 1, I get the square root of 4, and the square root of 4 plus 1 is 3. So I ended up with a perfect square. Then the next perfect square would be 9. To get 9 under the radical, I would plug in 11. So I would have the square root of 11 minus 2 plus 1 is the square root of 9 plus 1. So the square root of 9 is 3. 3 plus 1 is 4. So get 11 4. So let's plot those points. We're going to have 6, 3. And we're going to have 11 4. 11 4. And I noticed that the shape of this graph looks exactly like the shape of the graph of our parent function. It just moved to the right and up. All right. Why don't you go ahead and try example 2. Actually, for example 2, I'll help you get started and then I'll have you do example 3 on your own completely. So for example 2, we have f of x is equal to the negative square root of x plus 3 minus 4. This function is going to have 3 transformations. You have to describe the transformation that negative causes, the plus 3 under the radical, and the negative 4 outside of the radical. What 3 transformations are those going to give us? Go ahead and do that part on your own. All right, so your 3 transformations are this graph reflects over the x-axis. It's going to shift left 3 units and it's going to shift down 4 units. So now let's talk about our domain and our range. So I want you to go ahead and find your domain and your range on your own. Remember, you want whatever is under the radical to be positive. Use the least value of your domain to find your range. And then you should also be able to tell me what the starting point is with that information as well. Go for it. So, just kidding, there's a but. Sorry about that. So, you should have found that your domain needed to be greater than or equal to, x has to be greater than or equal to negative 3. Then you plug that value into the function to find your range, and you would get negative 4. So for your domain, you should have negative 3 to infinity, negative 4 to infinity is your range, and then your starting point is the point negative 3, negative 4. So let's go ahead and I just realized I forgot to talk about the x and y intercept from the first example. We'll talk about that in a second after we wrap up this problem. So what I'm going to do for this problem though is because there's so many transformations, it's not really easy to use a table. And you totally can if you want to use the table. Feel free to go through and do that. You're probably going to have some decimals you're going to have to deal with in your graph. That's fine. You do you. What I'm going to do is I'm going to take the parent function. I'm going to graph it with a highlighter here. I had the point 0, 0, 1, 1, 4, 2, 9, 3. And again, I'm just getting those points from the parent function. Those were the key points we used to help us graph that f of x equals the square root of x. Now remember, we made a note that whenever you have a reflection, you always want to reflect first when you graph. So what I'm going to do is this old parent function, I'm going to take each of those points and reflect them over the x-axis. So 0, 0, if I reflect it over the x-axis, is going to stay at 0, 0. 1, 1 is going to go to 1, negative 1. 4, 2 is going to become 4, negative 2. 9, 3 is going to become 9, negative 3. So there's that reflection. So I already took care of the first transformation. The second transformation is I need to shift left 3 units. So I'm going to take each of those points and I'm going to shift them left 3 units. So I'm going to take the point 0, 0 and go 1, 2, 3. I'm now here. I'm going to take 1, 1 and go left 3, 1, 2, 3. I'm going to take the point for -2 and go left 3, 1, 2, 3. And then 9, sorry, yeah, 9, 3 is going to become, 9, -3 is going to be 1, 2, 3, 6, -3. And so now my graph is right here. But there's one more transformation that we need to do, and that is shift down 4 units. So now I'm going to take each of those points and I'm just going to move them down 4 units. I'm going to erase the red ones because I don't need them anymore. I'm going to leave the parent function though, just so we can compare them. So now we're going to shift down 4 units. So 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. And I've just taken each of those points and shifted them down 4. There we go. And it looks like our starting point is -3, -4, which is what we figured out algebraically. So that matches our graph. It looks like we did reflect over the x-axis. We shifted down, we shifted left. We took care of all of those transformations. So our parent function went from here to here with those transformations. All right. So I'm going to erase this so I don't have my, there we go. Now we need to talk about our y-intercept and our x-intercept. So as you can see, this graph never intersects the x-axis. From our starting point, we're headed off this way in the positive x direction, but our y values keep getting smaller and smaller. Oh, actually, I just realized I made a mistake in my range, huh? Because our y values went from being positive and are now negative and are going to continue getting more and more negative, we actually need to fix this range. It looks like -4, because of that reflection, -4 is actually the greatest value y is ever going to be. And we need to include all the y values up to that though. So -infinity to -4 is actually our range for this function. Yay for bells. We just talked about how there's no x-intercept, so I'm saying none for my x-intercepts. For my y-intercept, we have a point here. Let's just plug in 0 for x and see what we get for y, just to make sure that we know what that actual y value is. So when I plug in 0 for x, I'm going to get -0 plus 3 minus 4. F of 0 is the negative of the square root of 3 minus 4. So it looks like it's -5 point something. So the square root of 3 is, give me just a second. So I just brought up my handy dandy calculator. The negative square root of 3 minus 4 is -5.7. So -5.7, 0, -5.7 is our y-intercept. All right. Which the graph kind of shows that. It's not perfect, but it's good. Okay. I can see that working for our graph. So there we go. We've answered all these key questions about our graph. We've got our y-intercept, our x-intercept, domain, range, and our starting point. All right, let's go back up here and just make sure everything's good. All right, our range does start at 1, and then it goes up to positive infinity. So that's good, just double checking that. So, but as you can see, this graph doesn't cross the x or the y axis. So for our x and our y-intercept, you're just gonna say that there are none. All right. Now, why don't you go ahead and deal with my calculator here, since it's in the way. All right, why don't you go ahead and do example 3 all by yourself. See how far you can get without me. So you're going to describe the transformations just by looking at the function, and then you're going to start graphing it. Remember, you can either use your table as your graphing, or you can graph the parent function and then literally do your transformations to the points from the parent function. All right, good luck. All right, so here's my graph. The first thing I identified were my transformations. This adding 5 directly to x will shift us left 5 units. Adding 5 to the whole function shifts us up 5 units. I found my domain and range to be -5 to infinity and 5 to infinity. And my starting point would then be -5 and 5. My y-intercept, when I plug in 0 for x, I'm going to get 7.2. And then what I did was, I noticed because I shift up and to the left, I'm never going to cross the x-axis, so I don't have an x-intercept. I noticed that if I plug in these x values, I'll get integers for my answer, because -4 plus 5 under that radical gets me the square root of 1. And then I just added 5 and got 6. Then if I plugged in -1, I would get the square root of 4, which is 2, add 5, I get 7. If I plug in 4, I'm gonna get the square root of 4 plus 5, which is the square root of 9. Square root of 9 is 3, plus 5 is 8. If I plug in 11, the square root of 11 plus 5 is the square root of 16. Add 5 to that is 9. And then I just plotted those points and drew my graph. So my starting point was here. I'm rising to the right for my end behavior. All right. Hopefully our graphs look the same. And if you have any questions, just let me know. Go ahead and get started on your extra practice, and I'll see you back in class. Have a good day.